In this video, we'll be talking about enthalpy change. So enthalpy change, or the total enthalpy change, means the total change in heat. Enthalpy is heat, and enthalpy change is because of the bonds that were broken in the reactants, and then after the bonds that were formed in the product. So remember what I told you about when I'm breaking the bonds, it's like earning money. So I am earning the energy, I'm absorbing the energy first, and then I spend the money when I form the bonds. So now imagine that if I were to earn $10, right? If I earn $10 and if I spend $9, what is the overall change? So you can tell that I would have a positive $1 change, right? Positive $1. However, let's say now I earn $10, right? I earn $10, so I plus $10 into my wallet, and then I spend $20 out of my wallet. So total, I will get a total of, right? What I get? Minus $10. So I overall lose $10. So this is the same thing when it comes to chemical reactions. The total enthalpy change, right? It's actually the energy that comes in, right, minus the energy goes out. So the money that comes in minus the money goes out. That's what we have been doing. And one thing that we need to take note over here is that the sign is very important. The final sign is very important because the final sign will actually determine whether it's going to be an overall exothermic or overall endothermic reaction. So let's try something with this question. So we did something very similar. Now we are calculating the total enthalpy change when 2 moles of water is electrolyzed. So this is water, electrolyzed, it forms this H2 and O2. So I'm just going to draw it out. So H2O looks something like that. I hope you know how to draw your dot and cross. And then H is single bond, so it will look like that. And the O2 is a double bond, so it will look something like that. So this is back to chemical bonding. Alright, so let's draw a small little table. And let's see what are the bonds broken and what are the bonds made. So bonds broken, bonds break, and bonds make. So let me count again. I'll highlight one by one with you. So I got a HO here for breaking. And then, so what do I got? I got HO bond. And how many do I have? I have 1 here, I have 2 here. But wait, because I got the coefficient here, it's not 2. I actually have 4 of them. Okay, I got 4 of them. Right? What about the bonds that I made? So the bonds that I made, I have a HH here, and I also have a O double bond O here. How many do I have? So as you can see, I got a 2 here, so I got 2 HH bonds here, right? And the O, I got 1 double bond O. So the total amount of bonds I have broken is 4H over here. So the total enthalpy change, so this is read as delta H. Delta means change. Okay, delta change, right? Delta H is equals to me breaking 4 OH bonds, right? I broke 4 OH bonds, and then what I made was I made 2 HH bonds, right? And then I also made 1 OO bond. So you can see like the math is a bit complicated. So my suggestion to you is to not do this. Don't do this. Alright? My suggestion to you is to actually, in this table over here, draw it and do the calculations here first. So bonds broken, you can do the calculation here. The delta H over here is 4 times this one, the 4, 6, 5. because that is the OH bond. So let me take out my calculator. 4 times 465, that is equals to 1860 kilojoules per mole. Alright, so 1680 kilojoules. Oh, not per mole, sorry, kilojoules. Right, then what about the other side? So the other side, delta H is equals to 2 times this one here, 432, plus 1 times this one here, 498. Okay, please be careful when you look at this. We want the OO double bond and not the OO single bond. Right? It's not the same. Huh? Okay, so let me use my calculator for this. I'll have 2 times 432 plus 498. So this will give me 1362 kilojoules. So the energy absorbed to break the bonds, right, is 1860, and the energy released to make the bond is 1362. So this is like the energy we earn, the money we earn, and this is what we spend. Okay, so the total, so that's why I said this part don't do like that, it's a bit confusing. Show this working, so that I can give you working mark. And then you write delta H is equals, make sure you write out the working so that I can give you working mark, is equals to 1860 minus 1362, and this is 498 kilojoules. So then you write 498 kilojoules here. But wait, this will be marked wrong, because as what I mentioned over here, the sign is very important. You must show that there is an increase. The sign is very important. So because this is not a negative number, you must put the positive number there. Okay, you must. So then you put a positive number, and that's the final answer. Please remember that. Okay, so with that, I end this part about total enthalpy change.